Here it comes the most interesting part of this chapter, the escape velocity. The escape velocity. What is the escape velocity? All right. So let me dive that. I love the word escape velocity. All right. So what is escape velocity? If I ask you, you know that you already know. Basically, I believe that you know. The escape velocity is the velocity which is given to any object whatever we want to send outside of the earth. Okay, the minimum velocity required to get rid of earth's gravitational field is called the escape velocity, right? So if you don't get that velocity, then you won't be able to get rid of the earth's gravitational field. You always rotate with earth. Wherever earth will go, you have to go with the earth, and you cannot escape the gravitational field if you do not have this amount of velocity minimum. You need to have that velocity, right? So now we want to calculate in this class what is that velocity we want to have to get rid of the earth's gravitational field. All right, so basically you have to calculate that. We have seen that the gravitational potential energy is gmm by r. All right, so if the mass of the earth is capital M, the mass of the object is small m, then the gravitational potential energy is basically the potential energy. You can name it potential equal to minus g m m by r, right? From where this potential energy is coming, because any object, you, me, your house, your teacher, your computer, or anything, whatever is residing over the surface of the earth, they all have this potential energy, this minus g m by alpha. G is the gravitational constant, m is the capital M is the mass of the earth, small m the mass of you, me, or your computer or your phone or anything, and r is the radius of the earth. Now in order to get outside of the earth's potential energy, like a couple of days ago, the owner of the Virgin Mobile, he went to the space, and what he essentially they have built one airplane which has the escape velocity, and that's how they went outside of the earth's gravitational field. Now when that person went outside of the gravitational field, that means he has to he has to supply a amount of energy which is basically nullifying the potential energy. Okay, so now what is that energy? From where this energy he's getting that energy? He's getting that energy by the velocity of the plane what they have made, right? And if you have a large amount of velocity, then you will gain a lot of kinetic energy. So in order to suffice this potential energy, we need to have the kinetic energy, right? So if the kinetic energy equal to or greater than the potential energy or gravitational potential energy, then only we can escape the earth's gravitational field. Alright, so let's say this rocket which is moving outside of the earth, let's say it has the velocity v, and this v, basically if that is the velocity and if that is m is the mass, then kinetic energy of this rocket is half m v square. Now it has to be greater than the potential energy of the object, right? Or let's say for the boundary case, this kinetic energy equal to the potential energy. All right, so let's say equal to the potential energy, or you can say in this way that gravitational kinetic energy and the sum of the kinetic energy and the potential energy would be exactly equal, and they are scalar quantity. We know that the energy, so that's why we are not considering the direction and all that stuff, right? So directly I can write is gm m by r. Now you can say that's where the sign minus sign went. So basically I told you that kinetic energy, the sum of kinetic energy and the potential energy, that should be 0, right? So basically kinetic energy, potential energy, if I do that, then half mv square plus of minus gmm by r equal to 0. So from this equation we can get this part, right? We can get back to this point. So if we do that, then what will happen? This v will get cancelled from the both side, and the sorry m will get cancelled from the both side, and v will be equal to, that is g capital M r 2 and square root under the square root. Now this is the formula for the escape velocity, but we can tweak this formula a little bit. How? So we know that g equal to gm by r square. So g r square is equal to gm, and so from this equation we can easily get the replace this value of the gm over here, and g r square by r, and obviously there are 2 we have, and we have 2g r, and that is the value of the v. So this is the formula of the escape velocity. So you should square that inside of the square, and if you now calculate what is the value of the g for the earth, then you'll be able to see the v is equal to root of 2 into 9.81 into 6400 into 10 to the power 3. So if we simplify this equation, it will become 11.2 kilometer per second. Understand this point, the 11.2 kilometer per second, that means this rocket has to move 11.2 kilometer in 1 second. If it launches from the some space over the earth, it has to move 11.2 kilometer in 1 second, and then only it can go in space, it can go anywhere, just breaking the earth's gravitational field. All right, so this is the idea of the escape velocity. There are lots of numericals we need to do from the escape velocity. Okay, see you in the next class.